And hello, everyone. My name is Courtney Clark. I serve as the Program Director of Everywhere She Maps for the YouthMappers Network. I'm excited to tell you more about Everywhere She Maps in just a minute. But first, I want to welcome you to this session focused on QGIS or QGIS. We're extremely lucky to be joined today by Rory Nealon and Christine Urbanowitz, who are going to take you through a really exciting hands-on workshop that will give you all the tools you need to get started using maps in this amazing piece of software. Just as a reminder, please download the data set that I emailed to you and make sure that you have QGIS downloaded as well. All of this should be in your inbox. Please feel free to introduce yourselves in the chat and to put questions in the chat throughout the session. We'll get to them as best as possible. We are having a live poll right now, so please make sure you put in your response to the poll. Your answers are completely anonymous, but they're extremely helpful to us. And as a final reminder, please make sure you keep yourself on mute unless you are asking a question. So before we get into the workshop itself, I want to just provide a quick introduction to Everywhere She Maps. This is a program within the YouthMappers network that we have designed to increase women's participation and support women mappers throughout the network and throughout OpenStreetMap. We really want to strengthen the inclusiveness of the geospatial community by building technical capacity of women mappers, enhancing their professional and networking skills, and contributing to and leading mapping campaigns that focus on adding data to OpenStreetMap that is particularly relevant to women and girls. We do this through 4 core activities. So the first is our professional development activities. Part of that is the workshop that you are attending today, or if you've attended any of our other workshops previously. We also have an internship matching program where we match YouthMappers students with hiring organizations so they can have professional experiences. We also have 8 amazing regional ambassadors from around the world who are really our boots on the ground and our voices in the field, connecting with chapters and working with them on solutions to increase women's participation in their chapters. We also have a variety of mapping campaigns that we lead, or we're in the process of about to launch projects that add data to OpenStreetMap that's of particular relevance to women and girls. For example, we have a campaign currently in Sierra Leone where YouthMappers chapters are mapping parts of rural Sierra Leone to help the country increase access to electricity. And then finally, COVID pending, we are hoping next year to launch our Women in Technology Leadership Fellowship Program as well. We have more sessions in this series coming up. The next sessions will be kicking off in January of 2022. This is our last one for 2021. If you go to the YouthMappers Eventbrite page, you can see all of our upcoming events. You can also follow us, and then you'll receive an email notification every time we publish a new event. So strongly encourage and invite you to come to all of our future online sessions as well. And with that, I'm going to pass things over to our fantastic presenters. Thank you, Rory and Christine.
Thank you, Courtney. Just give me a second to share my screen. Cool. Okay, well, yeah, so good, whatever time of day it is in your location. It's morning here in Baltimore, Maryland, but I'm sure we have people from a lot of different time zones here. And especially thank you to those who are waking up early or staying up late to attend. We really appreciate it. My co-presenter and co-colleague, Christine, and I are really glad you're able to join. I'm Rory Nealon, and I'm a senior GIS analyst and the activity manager for the YouthMappers program at the U.S. Agency for International Development, or USAID, or USAID. I'm going to use all the different pronunciations for that throughout this presentation, but it just means the same thing. People just use pick whichever one they like to say. So real quick, what is USAID? It is the federal office in charge of coordinating the United States' assistance to the rest of the world. At USAID, Christine and I both work at the GeoCenter, which supports the entire agency with its mission by providing a geographic approach to international development and humanitarian response. So before we dig deep into today's presentation, I would like to set out the training objectives, our schedule, and expectations. First, the objective of this training is to provide the attendees, that's all of you on the call, with a basic understanding of geographic principles so they can apply geographic techniques using GIS software to manipulate, transform, and style data to make maps that display data with integrity and helps answer questions that are spatial in nature. Today's training will be structured as such. To start, we'll cover some geographic basics and GIS basics. You might already know a lot or all these concepts, but it'll be good to get a refresher, and you might not have heard of them discussed in this way, so you can kind of maybe steal some of the ideas and use it in your own presentations when you're talking about GIS and geography to your colleagues. Then I'll hand it over to my colleague Christine, who will do a QGIS basics intro, followed by some geospatial analysis basics in QGIS. Expectations. What are our expectations for attendees during this training? First and foremost, it's to listen. If you're not listening, then how do you expect to learn anything or hear when I mess up or something like that? Next, we expect you to participate. It's the best way to learn, right? This is an opportunity to get help you need to master these skills, so please follow along and please ask questions. Christine is a amazingly talented geospatial data scientist, and it's a unique opportunity for you guys to have someone like this leading a training for you, so please take advantage of it. And then finally, be nice. We have lots of different people here with a lot of different backgrounds, skills, and experience, and everyone has the right to learn and be heard. So hopefully that makes sense to everyone. So I think a good place to start is what are maps? As you can see from this Dutch master Johannes Vermeer's 1668, approximately 1668 painting entitled The Geographer, maps used to be these painstakingly hand-drawn documents. You had to wear fancy clothes and have specialized equipment. But luckily for me and you guys, since about the 1980s, maps have mostly been made with the aid of computers, which makes things a lot easier. Maps made on computers are built from different data sets. This data can be a single point, a collection of polygons, or a photo-like recording of color, a raster. This data, the map on this slide consists of point vector data for the location of cities, line vector data for the state's boundaries, and a raster data set to represent the percentage of days the temperature exceeded 0 or 100 degrees Fahrenheit. And we'll go more into those different data types in a little bit.
Rory, we're not able to hear you right now. Oh, I think we might have lost Rory for a moment. I'm sure he'll be jumping back on quickly. So thanks for your patience. As I'm sure you're all aware, we all have our different internet issues from time to time. Oh, looks like Rory's back. Rory, are you able to hear me?
Yeah, can you guys hear me?
We can hear you now, yeah.
Cool, great. Sorry about that, I just lost connection.
No worries.
I'll redo this slide because I think we covered the last. And if people don't mind turning off their video cameras just to make sure we have as much bandwidth for the presentation as possible. Cool. So with
Yeah,
data,
we
calculate-
can't see you have to reshare your screen though, I think.
How about that?
And Rory,
That looks
your
great.
audio's a bit lower now. We're having trouble hearing you.
Troubleshoot audio really quick.
And just in case folks didn't hear, if you're not Rory, could you please turn off your video? This will make it easier for Rory's internet to be stable.
Okay, is the audio better now?
That is much better.
Great. I will reshare.
Thank you. Perfect.
Great. Okay, so I'll restart this slide. Apologies about that again. So with data, we calculate numbers and make pictures like maps. When calculations are performed on data, we analyze it. This means we transform the data by doing things like aggregating or summarizing it in some sort of way. The process of making a picture from data is called symbolization. This is when we make decisions on what visual element will represent different parts of the data set. We can see in the picture here, we have size, shape, color, hue. These are all different decisions we'll need to make on how our geographic data should be symbolized. Symbolization and analysis are two parts needed to make a map. This training will introduce you to these basic concepts and then have you apply different techniques for symbolization and analysis. But before we do that, why should we even care about maps in the first place? That's what Garfield's thinking, right? Right, so why do maps matter? First of all, they're really cool. This is a map of Amsterdam, of buildings in Amsterdam in the Netherlands, color coordinated or symbolized for the data each building in the city was built, or excuse me, for the date each building in the city was built. The darker red buildings are the older buildings. The blue and white buildings are the newer buildings, and the orange buildings are the kind of in the middle, in between. So you can see there's a downtown core. Hopefully you can see my mouse over here. That's the old town. And then these darker orange areas over here are a little bit newer. Light orange, much newer. Blue and white, very new. So I just think it's a cool map. Maps are informative. They contain information that tells a story. This is a humorous map showing Americans' prejudices about European countries. This author has also made maps of the reverse, right? European prejudices about America, and there's a whole atlas of it. I suggest you Google it around. You've probably seen these before. Maps are really useful, right? Maps are tools for understanding our planet. They have and are being integrated into different services, and geospatial technology companies use it to power a lot of their services, even ones you don't think of, right? Facebook and Apple, we probably don't think of them as mapping companies, but they have a huge mapping team and huge spatial data services teams because the question of where is so important. And everyone has a smartphone, or hopefully has a smartphone with a map on it, right? If you do have one, you're going to have a map on it. A question I get asked a lot, and as a geographer, and maybe you as geography students or people who do a lot of mapping projects, are probably, hasn't the entire world been mapped already? Like, why are you doing on this? We obviously know this is wrong, since our planet and the forces on it are dynamic and ever-changing. Humans' impact on climate change, for example, has caused the ice at the North Pole to melt at an alarming rate. We need maps and geospatial analysis to understand our impact on these changes, right? So we need to understand how the North Pole has changed. From 1980, the map of the North Pole looks a lot different from 2011. And with better technology and better satellite imagery and better tools, we're able to more accurately map that area as well. So not only are things changing, but our ability to map that area is improving as well. And I'll just end this section with another map that I really like. This is one of my favorite historical maps. This is a map of the Mississippi River, the longest river in the United States, and about the third longest in the world, depending on how you measure. And the map shows how the course of the river has changed over time. I find this interesting because the border between the states of Mississippi and Louisiana are fixed on the boundary of the river. When it changes courses, it creates small enclaves that states have to trade back and forth to make sure that there's not just a small part on the wrong side of the river. So it was a treaty that said the middle of the Mississippi is the border between these two states. But when the river changes, you'll have a little pocket on the wrong side of the river. This doesn't happen as much these days because of damming controls and other controls, but it used to happen a lot, and there's still some of them existing to this day. Cool. So now let's cover some basics of geography. Maps are representations of the real world, things that can be seen, like oceans, rivers, lakes, mountains, roads, buildings, and things that cannot be seen, like international boundaries, temperature, and air pollution. Does anyone know what the world is shaped as? Someone really quick want to come off mute and tell me what is the world? What's Earth? Is it flat? What is it? Courtney? Maybe I'll call on you.
Okay, sure. It's round.
Yeah, it's round. It's true, but I think a lot of people would probably say a sphere, right? But it's actually not a sphere.
Sorry, I didn't do well in geography or geometry. I mean, my geometry class. Thanks.
Right, but so a lot of people think a sphere, but it's actually an ellipsoid because it's not a perfect sphere, right? There's bumps, there's dents in it. It's mountains and valleys and things like that. So it's an ellipsoid. That's just a basic geographic concept we should remember. Cool. But being an ellipsoid, it's hard to take this 3D object and transform it so it fits a 2D plane, like a map. The classic representation of this is taking an orange peel and trying to flatten it. You can't without distorting it a bunch, right? So that picture shows we have this ellipsoid, and if we're trying to make it into a map, we have to really cut it and pull it and twist it and do all these crazy things to it just to make it flat. And this is true with maps and map projections. You have to distort the Earth's geography to fit it on that 2D plane of a map. When selecting a projection, that's how we transform the 3D object into a 2D object, we have to make compromises between preserving a map's shape and its area. And we can never do both in perfect alignment. So everyone's probably familiar with Mercator, the projection that Google Maps and OpenStreetMap uses, or a version of it called Web Mercator. That preserves the angles, but not the area of areas. So you'll see, especially near the poles, places like Greenland, really big. It's the correct shape, but it's way too big because it's preserving angles because it's designed for navigation and not for accurately representing the area of a place. Cool. So coordinates are the XY values given to a location on a map. Geographers call them longitude and latitude. Latitude runs around the Earth east to west, but moves north and south. Longitude runs north and south, but decreases and increases east to west. Geocoding is another important concept, is when you take text and get longitude, latitude back from it, a geocoder. So for an example, if you were to search for Sierra Leone in Google Maps, it would return the location of the country, and you could get the coordinates from that. Reverse geocoding is the opposite. It's when you give coordinates and the reverse geocoder gives you a name of what is there. Unlike physics or chemistry, geography is really easy because we only have one law we need to remember, because there's only one law of geography thus far. And it was written by Waldo Tobler, and it states that everything is related to everything else, but near things are more related than distant things, which kind of makes sense, right? If you think spatially, the things that are closer together spatially are usually have some type of closer relationship than things that are further apart. As I'm in Maryland, and the next state south of me is Virginia, and we're both in the United States. We're both kind of more related than ones that would be an area that would be further away. Cool. So quickly ran through some basic geography concepts. Now we're going to do some GIS basics. So geographic phenomenon we want to map can be discrete or continuous. Continuous geographic phenomenon changes gradually and is not abrupt. This can be for things like temperature, elevation, or water salinity, right? So here's a map of temperature, and you're not going to see very drastic changes in temperature, right? It's going to slowly change as you move across space. Other types of geographic phenomena are discrete. This means that they can be divided into distinct parts with everything in the area having the exact same value. For example, country boundaries are discrete, as are building footprints or roads. So here's a map of Sierra Leone, and you can see the administrative boundaries or provinces inside the country are very discrete, right? Everything within that area has the same value. Everything is Eastern Province, Northern Province, Southern Province. Where am I? Sorry, I lost myself for a second. To symbolize our geographic phenomenon, there are different types of data we use. And we have to match our data to the right type of phenomenon to make sure we're representing the data in a fair and honest way. In general, our data can take 4 forms. First, nominal, which provides an identifier to distinguish different values. An example would be the names of countries to distinguish the different boundaries from one another, like that map I just showed you guys. Ordinal data, which can be put into a natural sequence, think data that would have like high, medium, or low associated with it. Then integral data, which allows for simple forms of computation like addition and subtraction. Examples of integral data would be time, date, temperature, or a pH scale. Then finally, ratio data, which allows for most, if not all, arithmetic computations. Think of different data that has a number associated with it, like population, statistics broken down by age or gender. Cool. Before I pass the presentation over to Christine for the fun stuff, I will talk about how this data is stored. All the different types of data we just discussed can be stored as a vector or raster file type. However, there is usually one format that is more efficient than the other. A raster is a grid, regularly spaced cells with a value associated with it. The value of the cell is assumed to be valid for the area within it. In this example, you can see the black part of the grid that forms the face is given a value of 1, and the white cell is given a value of 0. So here's our raster grid on the right. You can see the white space has a value of 0, and the black spaces have a value of 1, and that's just our GIS assigning those colors to those values. And that's what we do in QGIS or ArcGIS or ArcPro or any other GIS software. This is a more complex example where you can see the state of Oregon in the USA, and the pixels that make up the raster relate to elevation. So instead of just having 0 or 1 value, they have a value of 1 to -4 here. The other way to store data is vectors. Unlike raster, vectors attempt to explicitly georeference the geographic phenomenon they represent, right? So that it's the actual location and not just the area within a square. So let me just go back for a second. So every value within this little square here in this raster pixel is 0, and it's assumed to be true. And this doesn't matter maybe when you have really high resolution satellite imagery, because it might have a smaller area it's representing, so it'll probably be more accurate. But if you have a lower resolution satellite imagery, maybe something that's 30 meters per pixel, there might be a couple different values within there, depending on what you're trying to measure or look at. And so resolution really matters with rasters, and it matters as well with vectors, but you're trying to actually measure the exact location of something. And so it's just, you're not trying to encompass other, or it's unlikely that you'll have other values within that area. Cool. Let me Yeah, so vectors could be a single point, an XY, or an XY with a height, XYZ. Vectors can also be a line, which requires 2 or more ordered points, also called nodes, with a line drawn between them. So when you store vector data, it stores the points in a sequence, and our GIS software connects the dots because it knows the order which the lines or the dots have been drawn. Finally, vectors can be polygons, which are collections of nodes with arcs connecting them. The first and last node are the same point, meaning it forms a closed shape, right? So the first and last kind of circle there are the same, which encloses the shape, and you need a minimum of 3, right? 2 would only be a line, 1 would be a point, so you need at least 3 nodes and arcs to connect for it to be a polygon. Awesome. Each part of vector data can have different thematic, also called attribute data, associated with it. It can include nominal data, like the name of the feature, and ratio data, like the area of the feature, and everything in between. And so the data we discussed earlier can be attached to these geographic locations and points and areas and lines and rasters. Cool. Now that we have some basic GIS down and some geography concepts, the theory part is over. I'm sure you guys are all excited for that, because now it's the fun stuff where maybe I'll take some questions if there are any before handing it over to Christine for the actual training. And don't worry, I will be sharing these slides with everyone so you can review and reuse them as you like. Just going to check chat. Doesn't look like there. Oh, someone typed in the ellipsoid earlier. Great job, Dietrich. Cool. All right, Christine, over to you.
Sweet. Thanks, Rory. Can you hear me?
Loud and clear.
Sweet. All right. So hi, everybody. I'm Christine Urbanowitz. I'm also a geospatial data scientist with Rory at USAID. And we're going to be using QGIS. People also just call it QGIS. And the goal of this presentation is, well, it's not really supposed to be a presentation, it's supposed to be a training. So I wanted you guys to follow along with me. So hopefully you have QGIS downloaded, as well as the data that I think Courtney sent out yesterday or earlier today, depending on where you are, that has a data folder in it. It's called something like QGIS Download 2021. So you need both of those things, the software and the data, in order to do this demonstration. So because I want you to follow along, I expect that there will be questions or things that aren't working. So I really want you guys to feel free to ask these questions. You can ask them in the chat, and then we'll voice them for you if they need to be voiced, or Rory will just answer them in the chat. Actually, I see one question for you, maybe Rory, before we keep going, from Henry. How does one determine places with new and old buildings in the map you showed earlier? You want to answer that before we get away?
Yeah, sure. That's a great question, Henry. So the data set was created by the municipality of Amsterdam. They had a recording based on their land records of all the, or the property records of all the different buildings in their city. The one thing the Dutch do really well is take really good records and preserve them really well. And so a independent geographer is able to take those records, that data set, and make that beautiful map with it. I've known other people who were inspired by this map and looked to add the handwritten records of the properties to OpenStreetMap and attach the age of the building being built. and were able to recreate this map for different cities. I've seen it for like New York, for example, and I think at least one neighborhood of Nairobi, if I remember correctly. I wish I could do that for my hometown where I live in Baltimore, Maryland, but there was a fire in 1920 that destroyed all the property records. And so if your house is older than 1920, they just tell you it's from 1920 because they don't have any record to prove otherwise. So hopefully that answers your question. And maybe I will, in the meantime, find a link and post it in chat with a more detailed explanation of their methodology to create the map. Over.
Awesome. Thanks, Rory. Okay, so yeah, the data and link to the software should be in your inbox. I'll talk slowly for the first couple minutes, so if you need to get that stuff onto your computer, you can. And yeah, reiterating, please ask questions. So we're going to go over QGIS. QGIS is free and open source. Open source means people can download the data, the code that creates the program, QGIS, share it, distribute it however they want. They can also contribute to QGIS. So people make lots of tools that make QGIS even better. So different functions like overlaying different base maps onto your map. Because QGIS is free, you might think, oh, well, it's not as good as maybe ArcGIS. And that is definitely not true. There's so many wonderful things about QGIS, and some of the best GIS analysts that I know use QGIS in addition to Python and R. So I really like QGIS, excited to share it with you. If you are familiar with ARC, it's going to seem very familiar in some ways, and very familiar to a lot of GIS softwares. So the first thing we're going to do is open QGIS. So first thing I have to do is share my screen. All right, so I need to, open QGIS. I have a Mac, so this might look different for a lot of people. And I have QGIS 3.1. If you just downloaded QGIS, you're going to have a little bit of a later version. That's okay. Everything should look similar. Oh, and actually, I forgot to add the directions. So if you want to refer to directions now or in the future, Rory, could you pop the link in? Because I've lost Zoom now.
Yep.
So he's going to post a link to a Google Doc that has all the directions that we're going to be going over. Okay, so you can follow along with there. You can follow along with me. And we'll actually share that link later in an email so you can look at it and refer to it if you want to keep working on this project. So everybody should have QGIS open now, and you're going to create a new document. So all the way on the top left section, you should see this little blank page. So you're going to click that. That creates a new document or new project. And then we're going to add some data. So to add data in QGIS, you're going to use this little button that has like a red, yellow, and blue square. So it's called the Open Data Source Manager. Click on that. And then you'll see you can open lots of different types of data in QGIS. Vectors, which are point lines and polygons, and rasters are what you're often going to be opening. Rasters are those surfaces with pixels that Rory had, like the happy face. So we're going to be opening vectors, point lines and polygons. So make sure that's selected on the left. And then over on the right under source, you're going to click the ... button and open that folder that you had downloaded that was emailed to you yesterday. So mine's saved as a little bit different. So you should have 4 files in there. You're going to select everything in that folder. So they're all GeoJSONs. There's different file formats for saving vector data. These are all GeoJSONs. You might be familiar with shapefiles, especially if you use ARC, but GeoJSONs make it simple. There's just one file for each vector file. So I'm going to select all these GeoJSONs, all 4 in that folder that you downloaded and hopefully unzipped. And you're going to click open and then add. And then you should see that something pops up. So once that happens, click close. All right, so if you're following along, we're going to just go through these steps. So right now, say we're on step 1.4. So once we add data, QGIS, at least for me, really likes to crash. So you're going to save your project often. So you're going to click this little floppy disk and just save it as whatever makes sense to you. I'm just going to call it QBasics. All right. So that is the end of the first step. So now we're just going to talk a little bit about this software and just what it looks like. So the first thing you should know about is this layers box on the bottom left, this layers panel. So this will show you all the layers, in this case, all of our vector files that we added to our map. And you can see there's little check boxes. So you can click on the checkbox and that will turn on and off layers in the map. The second thing is this toolbar all the way on top. Lots of really useful tools. You can play with them right now. One thing you might want to play with is this magnifying glass, the zoom in tool. So it looks like a magnifying glass with a plus sign. If you click that, and then you can click in this map canvas to where you want to zoom into. So you either can click once or just draw a box to where you want to zoom into. And then the final thing you should know about, and we'll be using a whole lot, is this processing toolbox on the top right. And it has so many tools that come with the software without any additional downloads needed, that we're going to use to process these data. All right, so
Christine, sorry to interrupt.
Yeah.
I don't see the processing toolbox. Do you know where I can add that window?
Yeah, that's a good question. Do you see, I think it should be under view panels. Okay, so on the top, you should have this little menu with words. One of them is view. And then it should, if you go all the way down to panels, you should be able to click what panels you want. And one of them is the processing toolbox. Does that work for you?
Yes, thank you so much.
Yeah, awesome. Thank you. That's important because I'm going to keep saying processing toolbox. All right. Let me admit this person. Okay, so we're going to look at some of these data. So in the layers panel, if you right click, so you see how the first layer, it says health sites, MOS projected, and it's a little point, little dot. That means it's a point file. So you're going to right click on this point layer and click zoom to layer. That will make our area of interest just in focus so we can see everything that this point layer includes. If you right click on that health sites layer again and go to open attribute table, we can look at what this data includes. So I downloaded these health sites data from healthsites.io, and that information is in that Google Doc that Rory shared a link to. Healthsites.io, and Rory knows a lot more than I do, but they are health sites data, so doctor offices, clinics, hospitals that are mapped and contributed to by the public. They're not comprehensive, so not every health site is mapped, for example, in Mozambique, only the ones that the public contributed to healthsites.io. And It's updated frequently when there's edits to a data layer. We can see for this data layer for health sites MOZ projected, there's 1,007 points, which means there's 1,007 health sites that I downloaded from this website. And each row in this attribute table represents one of those points, so one of those health sites. If you click on the numbers all the way to the left, that will select a point and they should be highlighted in yellow on your map. There's so many that they overlap, so they might be hidden underneath each other. All right, so each column in an attribute table is called an attribute, which totally makes sense. So for example, let's look at this amenity attribute, the second one. These are all tags that someone gave this point. So for example, this first row, someone labeled as a clinic. You can scroll all the way down and see that there's pharmacies, hospitals, doctors' offices. I think there's dentists too, at least for some countries. And I think, yeah, that's all we want to see for that one. Let's look at the attribute table for the grid information. So grid MOZ projected, if you right click on that and go to open attribute table, there's only 2 attributes. So what I'm showing here, this layer shows a modeled electric grid. It's modeled because some very smart person figured out how to predict where the electric grid runs based on a lot of other data. So for example, they looked at nighttime satellite imagery and figured out where in the country was bright and lit up and predicted that there must be electricity there because there's a lot of lights. And they looked at road networks and predicted that electrical grid lines would follow road networks because that would just be a pathway of least resistance. So all these lines, all these rows represent line segments of this electrical grid. And a lot of them are sourced from Grid Finder, which is just this model that predicts where an electrical grid should be. Others are from OpenStreetMap. So that might be a YouthMapper who helped map these electrical grids on the ground or by looking at satellite imagery. All right, so our goal here is to think about how far away health sites are from electrical grids. And that gives us an idea of if they might have electricity, how likely it is that we can provide them with electricity easily. And of course, we care about that because a health site with electricity is going to be able to deliver better health services. All right, so first thing we want to do is convert our electrical grid information, which is currently a vector. It's a line file. We're going to convert it to a raster. And we need to do that just because our next step requires a raster input. So anytime you need to do something to data, you're going to go over to the processing toolbox. And you definitely don't need to memorize what a tool is. You can kind of just search. So when I was searching for how to convert this line to a raster, and I didn't remember the exact tool name, I remember just going like vector to raster, and I found this tool. So in processing toolbox, you can just type in rasterize, and you'll see this tool pop up called rasterize vector to raster. So you're going to click that, double click it, and this dialog box should pop up. And I'm going to go through what you need to set in this dialog box. You certainly don't need to fill in every single thing. So under input layer, you're going to choose grid MOZ projected. That should be selected for you already. If it's not, you can just click on this and then choose the correct layer. So you want to choose that line file. For field to use for a burn-in value, leave that blank. For a fixed value to burn in, you're gonna type 1. So that means that wherever there's a line on that map, it's going to have a value of 1 in the raster file. So if you think about Roy's presentation, wherever there was a happy face on that image received a value of 1 in the raster image. So we're going to choose that. For output raster size units, you have 2 choices. Choose georeferenced units. So I know that the units of our data file are in meters. So I want this raster that we're making to also have units of meters. And I'm going to set the resolution to be 250 meters by 250 meters. So for width, horizontal resolution, type 250, and for height, vertical resolution, type 250. That means that each pixel in our raster represents a footprint of 250 meters by 250 meters on the ground. I chose this a little arbitrarily. You know, high resolution is always great, but there's drawbacks such as it takes your computer a whole lot of time to process, and it creates a large file. So 250 meters, I would consider a lower resolution raster, but it's good enough for our needs. For output extent, we're going to go all the way to the right and click the ... and click Use Layer Extent. And you're going to use the extent from this grid MOZ projected. So click OK. And that is all you need to set. So going to click Run.
Hey, Christine, really quick while that's running, there's been a few questions about the kind of transformations and projections you're using. I think a lot of people had EPSG 4326 or WGS 1984, and it looks like you're using 42106. Maybe you could just cover like quickly how to do a transformation.
Yeah, Rory, could you just tell me, so I can actually tell you how you can get this raster information. So hopefully I sent the right the right data out to y'all, but just right click on this first layer, health sites MOZ projected, and go to properties. And then go to this I for information. So this should tell you the coordinate reference system. Hopefully, and Rory, tell me if it says EPSG 42106.
I'm going to ask the Den or Fabian, who've been asking those questions about it. Martha has 4326.
Yeah, hey Rory, this is Fabian. Hey, sorry for being such a bother about this, but I've been typing it in the search, but maybe my version of QGIS didn't have it downloaded, so I'm looking, working with projections, documentation in QGIS. There might be something that I don't have downloaded, so sorry for I'm still looking into it, but I've done the search, and I'm coming up like with the number Martha or Den are coming up with, but as soon as you look for 42106, nothing is popping up in my CRS.
Okay. No, I'm so glad you asked that. All right, we don't want that at all. That's weird. I don't know if I had downloaded it without not even realizing it. So you're going to reproject that data. So go to reproject layer. So type reproject in your toolbox, and then click on one of the layers that you want to reproject. It's going to be health sites MOZ projected. Clearly it wasn't projected for you. So your target, if you click on this little globe button here. You should be able to search. So Dan, you're saying that when you search for 42106, nothing pops up?
Yeah, that is correct. It's as if I need to download a wider CRS.
Okay, no worries. Yeah, that's weird. How about if you type in 5629? Does that work for you?
I'll have to go back to let me see, 5629. You said.
Yeah.
That seems to be working for other people.
Okay, awesome. All right, so yeah, let me actually just close out because I'm going to need everybody to do this. So we need to reproject our health sites layer and our grid layer. They need to be in the same projection. We want a projection that uses meters as the unit and of measure. And they both need to be projected that way because we're going to do some overlay analysis. So they need to be in the same projection. So you're going to right click on health. No, you're not going to right click. Go over to the processing toolbox and type reproject. And you should see something called reproject layer. So for health sites, you can first choose health sites MOZ, and under target CRS, you're going to search for UTM zone 38 South. The easier thing to search for, though, is just 5629. Maybe Rory, you want to put that in the chat, 5629. So you should see that. It should pop up. Click OK. And then we actually want to save this file. So right now it's just going to be written to our temporary memory. We don't want that. It will disappear if we close. So we're going to save to file. And I'm going to call it, health sites UTM. Save and then run. All right, so now health sites UTM should pop up in your layers panel. We're going to do the same thing for our grid MOZ projected. So use the reproject the layer tool again. It should be in your processing toolbox. Choose your input layer as grid MOZ projected. And then under your target CRS, change it to 5629. Click OK, click run, click close. Oh, my bad. I should have saved it to my memory. Okay, so I'm gonna redo that. Grid MOZ projected 5629, and I'm going to save that as grid UTM. Okay, I hit run and I'm gonna hit close. Okay, so I'm going to remove the layers I don't care about anymore, just to make this a little easier to look at. So I'm going to remove the original projected layer for health sites. So I'm going to right click on it and click remove. And then the same thing for this junk file that I made by accident and this grid MOZ projected. All right. Did that work for everybody, or is anyone still following along, and did that work for y'all?
Yes, thank you. It's helping me reproject the layers in the right area. So thank you. Sorry for
No, I am so glad people are following along and have questions. So yeah, awesome. And thanks for bringing that to my attention. I actually don't know how I acquired such a large CRS library, so I'll have to look into that later. I've had this software for a while, so who knows what I did. All right, so.
Christine?
Yeah.
One question is, should we save it as a JPKG file?
You should save it. You could either save it as a shapefile or a GeoJSON. I'm not sure why you would put it in a geo package. Do you know, Rory? Like why? I just think it would just be easier for them to just keep it as a file in a GeoJSON or a shape.
Yes, I think that makes sense.
Okay. All right, so now we have to go back and rasterize this grid data again. So just be a nice review. Go into processing toolbox and click rasterize. So for our input grid, now you're going to choose that reprojected layer. So grid UTM. For the fixed value to burn in, type 1. For the output raster size units, tell it, I'm going to give you these units in meters, so the georeference units. I know the georeference units for UTM are meters. It's great for that. So for both the width and the height, you're going to type in 250. And then for the output extent, you're going to click the ... use layer extend, and then choose grid UTM. Click OK, and then run, and then close. Okay, so doesn't look like much happened, but something did happen. So you can zoom in to some little bit of area, and you'll see that you now have this very pixelated grid that is made up of these 250 meter by 250 meter pixels. If you think I'm going to remove this one. Let me see which one this is. Okay. Sorry. I still had another junk file in there. If you turn on and off this output, which is, the output from your rasterize function, you'll see that your original line vector layer is underneath. All right, so see, we converted to raster, so we're done with step 4. I don't think you're going to have any problems with needing to define the projection now, so we're going to skip the rest of step 4 because UTM really cooperates with QGIS. So now that we've rasterized our vector file, we're going to create a proximity raster. I don't know why, but I really, really like making proximity rasters. It seems like something that's really efficient to use later on, and it's very like a GIS savvy kind of thing to do. So you're gonna, I should tell you what we're doing. Go to processing toolbox and type in proximity. And you'll see this little like green button that says proximity raster distance. Double click on that. So for your input layer, you're going to choose this output. So that grid raster. For your distance units, choose georeference coordinates. So that means that I want this raster, every value of the raster to reflect distance in meters rather than distance in pixels. And I'll explain what that means and what we're getting to once we actually see the output. And I think the only thing you should change then afterwards is go all the way down. So scroll all the way down and change proximity map. You don't want to save it to a temporary file because that's just going to be deleted as soon as you close QGIS. So click the ... and save to file and name it something that makes sense to you. So I'm going to call it dis2grid. All right, click save and then click run. All right, I think that worked for me. Let's see where it ended up though. Oh, no, that's not good. All right, so for me, some reason it ended up over here on the wrong side of Africa. And that's just because the coordinate reference system wasn't set correctly. So you should be able to right click on Dist to Grid and go to Set CRS and choose that 5629 UTM 36 cell. And that for some reason didn't work.
Christine, do you need to set your project CRS?
No, that shouldn't matter because everything's on the fly, but I can try and see if that. Oh, right, because I opened it. Hold on. I'm going to just try redoing this to make sure I didn't do something stupid. Okay, for some reason it worked the second time for me. I don't know why, except for maybe what you just suggested, Rory. So if this didn't pop up for you, you're going to click on the bottom right where it gives you this EPSG. So this is the coordinate reference system of your project. Click that and click the 5629. That way you're not having the computer, try to project things on the fly with different projections. And then you're going to run this proximity tool again. So going over the proximity tool again, you're going to choose your output layer. Your distance units are going to be georeference coordinates, and then you're going to save the file. If you scroll all the way down, go to proximity map and save it to Dist2 grid. Okay. Save, replace, and then you're going to click run. I'm not going to click run because I already did it. Although, no, shoot. I'm going to, sorry guys, going off script because of the challenges we had. I actually need to save it as Dist2 grid. So, well, repeating everything we did, it's always good to learn that way. Distance coordinates, georeference units, this, save to file, Dist2 grid, replace, run. Oh no, Rory. I don't know where it ended up. Zoom to layer. All right, let's try. Set CRS, right click on that, set CRS, and choose 5629. What the heck? Any other ideas, Rory?
Oof. Can you, so yeah, projections are always the crazy thing with QGIS. It gives you so much flexibility, but it also means things can go kind of wrong, but this is where we actually learn. At least I do when things like this happen.
I have a feeling it might be something about me trying to rewrite. If I save it to a temporary file, it outputs correctly. So if this is happening to you, just don't save it to your computer. Save it to a temporary file, and we'll just keep working it with the temporary file and we can export it later. Yeah, this is the only thing I have no idea what is happening. So I'm going to remove this layer. And all right, so you should have this output, or it could even say Dist2 grid, which would be great if it's showing up over Mozambique. So what this is showing you is the distance between every single pixel and the closest electrical grid. It's hard to see, so actually if you take your output raster, that proximity raster, and drag it to the bottom so it's below the grid UTM, that'll give you just better context. So these pixels that are white all the way out in the ocean are have really high values because they're really far from the closest electrical grid. And then all these blacker raster pixels are, darker. They have lower values because they're closer to the electrical grid. So the last thing we're going to do is figure out what is the raster value that each health site is on. And so that's going to tell us, we're going to extract the raster value that's overlaying the health site, and that's going to tell us the distance between the health site and the electric grid. So under processing toolbox, you're going to type add raster values to points. So we're on step 6 if you're following on that Google Doc. Add raster values to points. Hopefully this is going to work given all the projection problems we've had. The points you're going to choose is health sites UTM. The grid, I'm going to close this and just create just one grid so I'm not confusing myself. So you should be able to choose the output or Distagrid if that was working for you. And then the result, oh dear, I'm just going to save this as a temporary file. So that's all you should need, except for this choose nearest neighbor as the interpolation technique. So points is the health sites. Grid should be that proximity raster that you just created. Mine's called output. Yours might be called Distagrid. And interpolation is nearest neighbor. I'm going to click run. And this actually takes some time. So if there's questions that I can answer, Rory, have at it.
Nothing from the chat, but does anyone have any questions at this point? Do we need to review anything?
All right. All right, so mine finished running. I'm going to hit close. And my result, since it's just a temporary file, because I don't dare save anything to my computer right now, is just called result. And you're going to open up that attribute table. So right click on that layer that was just created, go to open attribute table, and scroll all the way over to the last attribute that's called output. That was the name of our grid. That's the distance in meters between the health site, which is represented by each row, and the nearest electrical grid. So that's awesome. We see the first one, for example, is 500 meters from an electrical grid. I should mention, though, that there's lots of limitations to this. The first one is obviously our raster resolution is 250 meters by 250 meters. Therefore, our distances could be off by at least 250 meters. Also, because our electrical grid is modeled, and which basically means our best guess of where it occurs on Earth based on a lot of data, there's some inaccuracies in it. They estimate that it's about 70% accurate. And yeah, I think those are the two biggest limitations. The last thing I wanted to do, and actually we have plenty of time if we want to do other things, is summarize this attribute. So we're going to first ask, how many health sites are beyond 10 kilometers of the electric grid? So these are the health sites that might be the most isolated and need the most help. So under processing toolbox, we're going to type select by attribute and click the select by attribute tool. Under input layer is going to be that last point data set that you created. So mine is called result. And then under selection attribute, well, you want to select the points based on the distance. So select the attribute all the way at the bottom. That's your distance attribute. Your operator, you want to select all of the points that are greater than or equal to 10 kilometers. So choose the greater than or equal to sign. And then for the value, you want 10 kilometers, so that's 10,000 meters. So type in 10,000. And then keep this as creating new selection and click run. And then close. All right, so when something's selected in QGIS, it's going to be highlighted in yellow. So all these health sites that are highlighted in yellow are 10 kilometers or more from the electric grid. And if you look at your attribute table, which should still be open, if it's not, just right click on your layer and go to open attribute table. You'll see, you know, we had 1,007 total points and 250 of them are 10 kilometers or more from an electric grid. So about 25% of these mapped health sites. The second question we can answer is, what is the average distance between a health site and the electric grid? So to do that, you're going to go to Processing Toolbox and type in Basic Statistics for Fields. So you're going to click on Basic Statistics for Fields, double click it, and then in your input layer should be that point layer, so mine's called Results. And then field to calculate statistics on, you're going to go all the way down and click this distance attribute, the last one, and save the statistics to a temporary file. Yes, that's what we want. So you're going to click run and then close. All right, so our results viewer is a panel that should pop up below the processing toolbox. But because the processing toolbox didn't pop up, just if this results viewer isn't popping up, then go to View, Panels, Processing Toolbox. Or sorry, not Processing Toolbox, Results Viewer. View, Panels, Results Viewer. And click on Statistics within the Results Viewer. That is going to open up an HTML page with, in whatever browser you're using, with a lot of summary statistics. So for example, we can see that the minimum distance is 0 meters from an electric grid. The maximum distance is 104 kilometers from the electrical grid. And the mean distance is 7.5 kilometers, 7,500 meters from an electric grid. So those are all just super helpful statistics if you needed to create a report something to a USAID mission like Rory and I do all the time. These are numbers we would give them. So you can go back into QGIS and we're going to do two things. First, I want to save this point file that has this attribute with the distance attribute. Yeah, with the distance number. So you're going to right click on that layer, that last point layer that you made. So if it's a temporary file, you're going to need to just save it. If you already saved it to your computer, you don't need to worry about this. But since I didn't, I'm going to right click on it, click export, and then save features as. And I'm going to choose GeoJSON. The file name, I'm just going to say these are health sites, distance to grid. The CRS, this is important. So it should say EPSG 5629 UTM zones 38 south. That's what you want. So you're going to click OK. And now that's good. That's on your computer. It won't disappear if you close and reopen this QGIS project. Right, so Rory, we have a lot of time left. Are there other questions?
Yes. One question from earlier was related to the original health sites point data set.
Yeah.
They were interested. I saved it for the end on purpose, but they don't see the lat long on the attribute table, and I explained that's because the geometry isn't shown on there. But would you be able to show us how to add maybe the lat long to the attribute table?
Oh, that's a good question, Rory. Yeah, so this is a good way to just show that lots of times I don't know the exact tools in QGIS. Rory, if you just want to tell me, that's great. Or otherwise,
Sure, I can.
Yeah, otherwise I would be searching in this processing toolbox. So go ahead, Rory.
So the way I do it, and I think there's a couple different ways to do it, is to click on the little abacus in your attribute window. Little field calculator, I think it's called in ArcGIS. Can't remember the name. Yep. Just don't see the window yet. Okay, there it is.
Do you see it? Okay.
So this is how you, this is how you create a new attribute for your attribute table. And so the first thing you want to do is give the output field a name. So let's call it, X or something like that.
Yep.
And then we want to change the output type to decimal because latitude and longitude are in decimal degrees.
Okay.
And precision's 3. So that's precision is how many decimal places it is. Can we up that up to 5 just so we can be super accurate, even though it's probably overkill. And then if you go to the expression toolbox, I just have it memorized. So all you have to do is hit $, and then X.
There we go. Yeah, so this is going to be the latitude, but it's expressed as meters away from a northing that's based on your projection. So 36,000 or 361,000 meters away from a northing. Yeah. All right. So you would do that twice.
If
so
it was in a decimal degree system, you would do that. But there should be a more complex way to do it if we did a little transformation somewhere too.
Right.
But maybe for another time.
Yeah. So that is a nice way to do it. For me, a lot of times I'm just like, oh, I don't know, there must be a tool somewhere in QGIS. Go to processing toolbox, and I just started typing geometry because I wanted to add geometry to my attribute table. And what do you know? There's this tool called Add Geometry Attributes. And actually, you can calculate using the layer CRS. So that would be our UTM. You probably also could, if the project CRS was in WGS 84 with Latin long, then it would return Latin longs. All right. All right, so Rory, I know you had bonus material. I also have bonus material. My bonus material is creating a map based on these layers that we created. This is something that's all laid out for you in the Google Doc and something that you can just work on later if you wanted to. Clearly, there's no requirement, but there's instructions there on how to change the colors so it's actually something that you would want to look at and how to create a map. But Roy, do you want to go over what the extra kind of fun information you wanted to share?
I think to be honest, if you don't mind, Christine, I know you've been talking for a while, but I think the layout demo would be pretty nice right now.
Yeah, okay. All right, so this is actually a great reset point because if my failures as a GIS analyst confused you and you didn't get to do the proximity raster because the projections were wrong, you can kind of just restart right now. We're going to just work on symbology. You don't have to worry about having different data sets that we process. You can just use the original data sets that you downloaded and added to the map, you can change their symbology and make a map just with them. So I'm going to use the data sets we created, but it really doesn't matter. This is just to show you how to change symbology in QGIS, which is different and a little more clunky than what you might be used to in ArcGIS if you use ArcGIS. So to change, for example, the colors of this health site's distance to grid, you know what, we're going to start out easier. First, turn off layers you don't want to show in your finished map. So I'm going to turn off that ugly raster. And also I'm going to change the orders of my layers. So I want these international boundaries, large scale international boundaries. That's what LSIB stands for. I want that to be on the bottom. So I'm just going to drag that to the bottom of my layers panel. Next, I'm going to remove this temporary layer so I'm not confusing myself. And remove this one too. All right, so my grid UTM is this horrible tan color that you can hardly see. One easy way to change that color is just by double clicking on the layer and then going to this paintbrush. So the paintbrush on the left has 3 colors attached to it and it says control feature symbology. So you're going to click that and keep it as single symbol. This means that every single feature in our layer will be colored the same way. So you can change the color to whatever your heart desires. So I'm just going to choose this, say yellow for electricity. It makes sense to me. You can change the width if you want and make it a little wider. So I'll just choose 0.5 and yeah, that's fine. So I'm going to click OK. All right. For the point layer, you can do the same thing. So double click on the points that you want to change the coloration to. And actually, this is kind of like a little more advanced. Instead of coloring all the points in the same way, I want to color them based on an attribute. So if, say, I wanted to color them based on the type of amenity is, if it's a hospital or clinic or a pharmacy, you can go to categorized up here and then click on classify. Oops, sorry, click on value and choose amenity. So that means I want to color the layer based on the type of amenity is, and then click classify. Now you'll see that all the unique values for that attribute are listed and they're all assigned a different color. So you can click OK. And oh wow, a lot of them are clinics. Only a few of them are hospitals or doctors, according to whoever labeled these information and then put them into healthsites.io. I'm going to actually color them not based on this amenity attribute, but by distance to the grid. So double click on that layer again, go to paintbrush and change it from categorized to graduated. All right, so now I want to color it based on that distance attribute, which unfortunately for me is just called output, which doesn't make a lot of sense because, yeah, it should be called distance, but my raster layer was called output, so the attribute value is called output. And click classify. All right, so if I were just to hit OK right now, we would see that points were from white to red, white representing the closest points to the electrical grid and red representing the furthest points. I actually just want 2 colors, one for close and one for far away. So change the classes. I'm going to change the classes to 2. And then you can actually just edit the values that are used to classify the points by just double clicking within this white area where it says 0. Mine says 0 to 707. I want it to be 0 to 10,000. So all the points that are between 0 and 10,000 or 10,000 meters, 10 kilometers are going to be white. And then the second layer should automatically update. So everything 10,000 meters and beyond are going to be red. And you can change the symbology of each of these by clicking on the little dot. I just did that really quick. So just double click on this little dot next to symbol, and you can change the size and the color. So I'll say maybe everything, I don't know. I'm just making things up right now, guys. Everything close by will be orange, and then everything far away will be pink. So I'm going to change this. And actually, you can get rid of this ugly black line by clicking on simple marker and changing the stroke style to no pen. I think that just makes it look a little cleaner and flatter and nicer. So I'm going to do that for both of them. Go to simple marker and change this solid line to no pen. Okay, I'm going to click. Ooh, all right. That doesn't look very pretty right now. Let's see if we can make it look any prettier. So you can also change this Moz. So the outline of Moz, I'll just make it really dark. All right, so if I were going to change this, in the interest of time, I'm not going to keep working on the cartography, but I don't think those colors look very good together. I think the points are too big, but I just want to show you how to make an layout. So how to make a map from this, from our map layout, from our map canvas. So something that we would actually want to export and share with people. So to do that, you're going to go to this button right next to the floppy disk that says new print layout. It looks like it's a sheet with a star next to it, and you have to call it something. So I'm just going to call it Moz layout. Click OK. All right. So if you're following along still in the directions, there are just so many things you can add to a map. And this is completely just, you have creative freedom in how you design it, although there should be several elements to a map that you probably should have, including the map itself. So to add the map itself, go over to the left and find the little symbol that looks like a blank page with a plus symbol. So that's going to add the map to the layout. So you can just drag and drop the map into the layout. And then you can change the size of it by clicking on the boundaries. And let's see. Yeah, we're just going to add the elements. I'm not going to worry about the cartography right now because obviously this doesn't look that great. There's an example map in the document that I shared with you. Another important element that you should add to a map is a title. So if you click on this text box with the T and draw where you would want the text box. I'm losing my voice, Rory. You're going to change the title. I will say health site proximity to electrical grids, to the electrical grid in Mozambique. And I'm going to change the font size. So under appearance, you can change a lot of things. So obviously I would want to make it a lot bigger. And yeah, that's fine for right now. Again, I don't approve of this cartography that I'm using. All right, another thing that you would want for a map, unless it's like a world map where north is obvious, is a north arrow. So to add a north arrow, you just go back to this left-hand side, click the north arrow, and draw a north arrow where you would want it to be. That's one style of north arrow that you can use. You can change the image, what the north arrow looks like, by going somewhere over here, search directories, and changing the style of the north arrow. So you can choose any of the arrows that look like they're pointing north. All right. And then another thing you would want to add is a scale bar. So click on the little scale bar on the left-hand side, a bar with a plus sign, and draw where you would want the scale bar to be. There are just so many options for customizing how any of these elements will look. I am not going to go into them. I encourage you to just play around with it a lot. It would take so much time to explain all these different attributes, but you can change the units of the scale bar, what the scale bar looks like, the colors, everything right there. And let's see, last thing we would want is the legend. So for that, we're going to go to the 3 boxes with the plus sign and draw where we'd want the legend to be. So I actually am going to explain this one a little bit because legends are confusing. First, we don't want everything that's on our map to be in the legend. Like, I don't care that Mozambique and LSIB, they don't need to be in the legend. So to remove them, you're going to go to legend items over on the right and on-click auto update, and then click on the items that you don't want to be in the legend and click the minus sign. And then, you know, these are just our shorthand layer names. We don't actually want the legends to say health sites _ distance to grid. So you can double click on the text you want to change and edit the text. So I'm going to say health sites, and then 0 to 10,000 isn't going to make sense to people. So I'm going to double click on 0 to 10,000 and say less than 10 kilometers from grid. And then double click on the next one and say more than 10 kilometers from grid. Oh, I also don't want to have this second layer, so a health sites layer on our legend. So I'm going to click the minus sign. And for grid UTM, I'm going to change that to electrical grid by double clicking on that text and changing the text. All right, so once you made this all look very beautiful and you zoomed into the map, and you know, I would change the borders of these countries so they're not so dark and contrasted, you would export it. And to do that, you would use one of these, sorry, that menu keeps popping up, one of these export tools. I would choose export as PDF or image. So you click on this little page with an image on it and just save it. And that will save it as a JPEG. Choose the resolution and the page width and click save. I should say that you can change, and I should have done this, the size of the page. If you right click on the page and go to page properties, you can change the orientation, for example, to be portrait, which would make a whole lot more sense. And for this layer, and yeah, you can do a lot of things. There's instructions in that Google Doc. But Roy, I'm gonna get a cup of water, and you can go over your opponent's material.
No, thank you. Yes, totally. Thank you so much, Christine. That was really appreciated, and thanks for doing that on the fly at the end of the presentation. So as far as my bonus material goes, do you mind if I share my screen, Christine?
Oh, yeah.
Cool. I'm going to do a quick demonstration on how to export data from OpenStreetMap using the hot OSM tasking manager export tool. And I'm going to add buildings from the Netherlands, since there's a question about that earlier in the presentation, and quickly style them in QGIS by the date they were created. So I'm doing this on the fly, so apologies, I'm a little off script and it might not be as smooth as possible. Okay, so everyone should see the website I'm at, which is tasks.hotosm.org. If you have a OSM user account, you should be able just to log in. So I'm going to click log in and grant access, and it should load. Whoop, and it took me to tasks, but I'm actually going to export.hotosm.org, and I'm going to click on start exporting. And as you can see here, it brings up the export tool. It'll take us through 4 steps to get our data. First and foremost, we got to add a name for our export. So this is going to be Amsterdam buildings. And a description is useful if you're going to make this public and share it with other people, but for the purposes of this demo, I'm not going to do that. And then I need to select an area to export, because exporting all of the buildings in the entire world would be a giant file and take way too long. So I'm going to go Amsterdam, and that's the one. That box is a little too big. I don't need all the surrounding area. So I'm going to exit the search. I'm going to do my own little box and position it a little zoomed in and adjust the map. And I'm going to draw my bounding box. Great. And then I will hit next, and I'll ask for the format we want to export in. I do like GeoPackage a lot, JPKGs, just because in QGIS it works really well, and it's only one file you have to deal with. With shape files, as everyone should know, there's probably 4 or 5 different files you need to have for it to work properly. A projection, the shape file, the DBF file, and those can get lost sometimes, or if you rename one by accident, it'll break everything. So GeoPackages are much more neat and tidy for me. So I'm going to click next, but it doesn't matter. You can do shapefile if you prefer that. And you can select all the different types of OSM data you'd like to export. Since I'm interested in buildings, I'm going to click buildings, and I'm going to click this little down arrow where I'll be able to see different options from here. If I want the names and geometries, addresses, material condition. This is from the humanitarian OpenStreetMap team, so it's very much focused on humanitarian response. But I'm going to leave all 3 checked, and hopefully the date of the building will be included. There's more advanced configurations that you can do. To be honest, I've never used that before. I don't even know how to, because this has always suited my needs, just the basic features. I'm going to click next. You can add a buffer if you want, just to make sure you include all the buildings that maybe are, at the edge of the AOI. I'm not going to do this for this demonstration. And I'm going to create an export. And it takes a little bit to actually run, but lucky for you guys, while Christine was doing her demo, I ran it and already have the data. So hopefully you can see QGIS now. Please let me know if you don't. And I'm going to include my buildings layer. And I'm going to add everything. And we should see all the building footprints in Amsterdam. If you remember that map from my presentation earlier, it should look pretty similar to that. Obviously, Amsterdam is a city with lots of canals. It's built on the coast. So these large white spaces here are the kind of ring canals, and this is the old part of town. And as we get away, it should be newer. So if you remember from Christine, we're going to open attribute table. Oop, and it opened on my wrong screen. Oh no, I don't see, it did not export the building year. Oh man, that's a bummer. Yeah, like I said, because it's a humanitarian focused export tool, it doesn't include all of the attributes, and we would have to go back and improve the configuration for it to export that data. But I know it's there, and so maybe this will be a good excuse for me to learn how to do those advanced configurations. Because if we look at OpenStreetMap, I'm just going to go here. We can check if there is a building history or a building date. If we go to the location we're interested in, click edit, and select one of the polygons, we should see the start date, which is the year the building was built. And unfortunately, that's not exported, so I won't show you guys any more of that. Cool. Sorry about that. That's what happens when you do things on the fly. Go ahead.
Sorry, Rory. Not that we need to take more people's time, but I actually just wanted to show them the healthsites.io site too, so they can see how to just download health sites for their own country if they wanted to do a similar analysis.
Sure. Do you mind if I just do that while you
Yeah,
drink your water?
Yes.
Cool. So yeah, maybe just a little bit about healthsites.io. It's a project run. It actually started with USAID funding when there was a large Zika outbreak, and there was a challenge to look at innovative ways to address Zika in sub-Saharan Africa. And it's basically, you can think of it as another way to add OpenStreetMap data, but in a very domain health specific manner. So all the data in healthsites.io is in OpenStreetMap and vice versa. I'm going to let it track my cookies, and you can go up here to country data if you want to export data for your specific country. If people are familiar with the humanitarian data exchange, it also creates nice shape files and uploads it there as well for each country in the world. But here we can explore the data. We can check out Madagascar, for example. We can see in this town there are 1, 2, 3, 4 different health sites. And you can see on the base map as well that they're in OpenStreetMap, since it's just OpenStreetMap data. I'm going to sign in. Again, it should be linked to your OpenStreetMap account. And let's go to North America, and we can go, let's do the British Virgin Islands, since that's a tropical paradise I'd like to visit one day. We can see that this island has 5 health facilities. Again, matching OpenStreetMap base map, it's already there. You can see basically how complete they think the information is for the different data sets, so you can really dig in to see the information. And you can click on it and see the OpenStreetMap attribute data. You can even open up the location, the spot in OpenStreetMap, and click edit if you wanted to add more information there directly. So we can see this is a chiropractor named Pura Vida Chiropractor, and the other tags are listed down there. But going back to health sites, Oop, I think my computer froze a little bit. There we go. We can also edit it in here, which will link to OpenStreetMap as well. And so just as a reminder, you guys probably all know this, but one of the amazing things about open data is our ability to improve it and apply our local knowledge. And so if the data isn't perfect, we can contribute to it. And not only does our own organization or our school or ourselves benefit from it, but we improve the data for the entire world. So decision makers in other parts of the country or world can have the latest and greatest data. And it's a lot more detailed and health site focused here to help guide people in creating high quality health facility data, as opposed to the ID editor or JOSM, which is a more generalized editing tool focused on just general attributes. But this really helps guide people to make sure they're recording the right tags and information for healthsites.io. Christine, is there anything else I should cover?
Yes, Rory. Could you go to gridfinder.org? So this
Is this where you got your grid information?
Yeah. So you can download the entire world if you wanted. So if you just go to download, that will give you a TIFF. No, not a TIFF. It's going to give you that vector file with the high voltage and medium voltage lines. It's under grid.geopackage. So that's what you would download if you cared about that. And then there's actually a link to the paper that explains all their methods so you can understand why it's modeled data and what the limitations are. And you know, when you're using data, you really should look at their methods and understand how accurate the data are. So just wanted to share that with you. It's on gridfinder.org, and the link is also in that Google Doc.
Great. Thanks for providing the links to everyone. And I think we will leave it at that and hand it back to Courtney Clark to close us out. I just wanted to say thank you so much for attending and listening. And again, we will share the presentation and the recording and all the information in a follow-up email after this, so you can follow along. And we will also include our email addresses. So if you ever want to have a problem or stuck somewhere, Christine and I can help troubleshoot those issues. And if you want to send us a map, if you want to do what Christine did for Mozambique and send it to us, we'll be able to kind of review it and give you some suggestions on how you can improve it in the future. Thanks again.
Wonderful. Thank you so much, Rory and Christine. And thank you so much to our participants. We hope you learned a lot. And as Rory said, we'll send all of the items in follow-up. My last request for you would be if you would please take just a few minutes to complete an evaluation form of this session. This can help us as well as our presenters learn what worked well, what we could do better moving forward. And I have included the link to that in the chat under evaluation form. So please just take 2 minutes to get that done. If you are a YouthMappers student or alumni and you have attended the previous sessions, some of them in this series, keep in mind, if you fill out 3 of the evaluation forms for these professional development workshops and you give me your email address in each one, I will give you a personalized resume or CV review. So very helpful if you fill that out. And just want to say thank you so much for joining, and I hope you all have a great rest of your day.